We are up to 9.3 pre-lesson. What we're going to introduce to you, what I'm going to introduce to you, is an ellipse. Now in class, we'll have a little bit of fun with this. I'll actually take a piece of string and create a circle. Now, that shouldn't be a big deal. So what we do is we just take a piece of string, pick a spot, hold the end of it there, maybe hold the end of it there, really, and take a marker on the end of the string and just kind of like, remember the string is right here, and then just kind of take it all the way around. Now, terrible drawing, that's not what the lesson's about. An ellipse, I'm going to take two, this is called the center, and the center of an ellipse would be right about here, but I would take a piece of string and hold the end here, and maybe the string would be like that, and then I would take my marker or pen or pencil, tighten the string, and so now the string would be like this, and my marker's right here, and then if I actually these were stuck, and I tried going around, my marker would kind of go like this, and like this, and like that. Now maybe that's hard to imagine, but you got that going on, you got that going on, you got this going on, you got that going on. So this and this and this and this are just little pictures of snapshots of what's going on with that string that's going around and around. As you can see, this makes an ellipse, this makes a circle. Okay, terrible ellipse. Now, life applications, I don't think we're going to get into them too much, but if you watch the movie Hidden Figures, amazing. The mathematician had to figure out, because the orbit of a shuttle going around the moon or spaceship, rocket, would take an elliptical path around that moon. But then when it comes back to the Earth, to the elliptical pattern, the mathematician had to figure out how to turn an ellipse into a parabola for a safe return. Fascinating movie. Check it out. All right, we're going to lift the hood on this ellipse and show you the parts, the working mechanisms. So these things are called, well, that's a focus. Together they're called foci. Some say foci, some say tomatoes. I'm sure there's a right way, but I've never learned it. So this is where the string would be attached in my example that I just showed, but here's the parts. First of all, as you can see, I hope that we have this, which is part of the x-axis, and then let me get my purple marker, and then we have this, which is my y-axis. So, which one's longer? The red one, for sure. So this is going to be messy by the time I'm done. So because that red one's longer, it is called the major axis. So what do you suppose this purple one's called? That's the minor axis. Now it's made up of some parts. Half of the major axis is A. That means the other half is A. I'm just not going to mess up my drawing. And that makes this half B, which also makes that half B. Now, how about a green color? Hopefully this shows. That distance is C, from the center to the focus, which is the same thing here. So with all that being said, I want you to know that the general equation of this ellipse is x squared over a squared. Notice A is half of the major axis, and it's the x-axis. That's why A is underneath x, plus y squared over b squared. Notice B is half of the minor axis, which in this case is the y, and there's no coinkydink that it's underneath the y, and it always equals 1. Now, remember, circles, x squared plus y squared equals 9. This would tell us what the radius is. The radius would be 3. Got to change gears. Ellipses are always equal to 1. Always, always, always. Keep that in mind. Now, something else that this says and you should be able to see it, but I'm going to pull it out. A is always bigger than B. Keep that in mind. One more thing. Formula, a squared minus b squared equals c squared. So you're going to be expected to sometimes find the foci. You're going to need to know c. Sometimes you're going to have to find the equation. You're going to need to know a squared and b squared. This is your money formula right here. All right, let me pause this a second. All right, so I switched it. Notice it's longer this way. So my y-axis, this is now A, this is B. If I put a little dot right there, or I put a little dot right there, this is my focus. So this little distance would be C. Now something I didn't say, but it's on the board. The end of the major axis is considered the vertex. So we got one vertex there, we got one vertex there. It's not here and here, because that's the end of the minor axis. So this must be a vertex. This must be a vertex. Oh boy, I forgot something else. I hope it pops into my head. I'm gonna hope that it does. Okay, so let's talk about this one. We can see that it's the major axis is up and down. So this time it's going to be x squared over b squared plus y squared over a squared equals 1. Notice a is my major axis this time. It's the y part. That's why the a is underneath the y. My b is a distance along the x-axis. That's why b squared is underneath the x. Now let me pause and, oh yeah, it just came back to me. The focus, the foci, are always, always, always on the major axis. Notice, on the major axis, on the major axis. That's a big clue, because they're going to feed you some problems, and they're going to tell you, hey, the foci are blah, blah, blah. And by looking at it, you're going to go, oh, the y is the major axis, or by looking at it, you're going to say the x is the major axis. You're going to see some samples of that coming up. So here's a sweeping generalization of ellipses, and now we're going to put it together. So no sample problems on the pre-lesson. I'm going to save those for the examples video coming up.